Okay, for next question, that is question number 25, which says a narrow beam XY of white light is passing through a glass prism as shown in the figure, and we have to trace it on your answer sheet and show the path of the emergent beam as observed on the screen PQ. So this is the screen, and we have to name the phenomenon observed and state its cause. So let's draw it on a sheet of paper. So this is the prism. This is white beam incident. Okay. And this is the incident ray. Now, had this prism not been there, the path of the ray should look like this. It should go in it may have gone in this direction, but because the refraction is happening in the prism, so it will bend into seven different colors, or it will split up into seven different colors. So for one color, this is the refraction, and the splitting of seven colors, white light into seven colors is called dispersion. So it's 1, 2, 3, 4, 5, 6, and 7. And if this is a screen, so this will be the band of seven colors, which is called a spectrum. Okay. And the acronym used to remember these seven colors is WIBGYOR. So violet, indigo, blue, green, yellow, orange, and red. So this is the band of seven colors, which is called spectrum. So this is how you will trace. This is the incident ray. So this is how we'll trace it your answer sheet and path of the emergent beam as observed on screen PQ. And let's also give the direction with the arrows. Okay. And this is the splitting of white light into seven colors, and this phenomenon is called dispersion. Okay, now what is asked in the question? Name the phenomenon. So phenomenon is dispersion, splitting of white light into seven colors. So this is splitting of white light into its constituent seven colors. Okay, now what is the cause? What is the cause of dispersion? And the cause of dispersion is that this light consists of seven colors, and seven colors bend at different angles. So different colors of light causes that the different colors of light they bend through different angles. So that is the cause of dispersion angles. And it's with respect to the incident. And this is because different colors have different wavelengths. Okay. So cause is that different colors of light they bend through different angles with respect to the incident ray because different colors have different wavelengths. This is the answer for the first part. Now, beginning with the or, part, it is observed that power of an eye to see nearby objects as well as far objects diminishes with age. And we have to give reason for the above statement. The reason for the above statement is that with age, the defect that occurs in eye is because of the gradual weakening of the ciliary muscles and diminishing flexibility of the eyelids. So we have to give the reason. So we give a reason for the above statement why the power of an eye to see nearby objects as well as far objects diminishes with age. And the reason is that it is, this is all part, it is due to gradual weakening of ciliary muscles and with that diminishing flexibility of the eyelids. Okay, let me show you how. Let's say, let's suppose this is the eyeball. Okay, and here is the lens, which is held by the ciliary muscles. These are the ciliary muscles. So this is the lens, and these are the ciliary muscles. And we know that with age, these muscles will get weak. Now, the gradual weakening of the ciliary muscles, with this, there will be a lag in time to contract or relax the ciliary muscles, and hence the thickness and thinness of the lens will take more time, and this will reduce the flexibility of the eye lens, and hence we will not be able to see the far off and the nearby objects. So this is the gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens. You need not have to draw this diagram. I just drawn it to I have just drawn it to explain you how the ciliary muscles are holding the lens. Now name the defect that is likely to rise in the eyes in such a condition. So the defect here is presbyopia. So you're not, so presbyopia is the defect due to which you are not able to see the nearby and the far off objects because of the gradual weakening of muscles. So it's because of the gradual weakening of the muscles that here myopia and hypermetropia occurs in your eyes. And we have to draw a label diagram to show the type of corrective lens. So the corrective lens used for correcting myopia is the bifocal lens. Okay, so for this we use bifocal lens. Bifocal means we have both concave and convex in that. So we have both concave plus convex in that. And for the bifocal lens, we don't have any ray diagram. It's used in the specs. Let's say this is the one part of the spec. And in the spec, there the upper part, okay, here. So let's say this is one part of the spec, and here the upper part, this one part. This part will have concave lens. So this is the concave lens, and concave lens is used to see for distant vision. This is for distant vision. And the lower part will have the convex lens. So lower part will have convex lens, and that is for the near vision. So we don't have an actual ray diagram, rather you will use one because it's a bifocal lens. So you will use uh, one part of the specs, and the upper part will have concave lens for distant vision, and the lower one will have convex lens for near vision for the near vision. So this is how you will draw a well-labeled diagram used for restoring the presbyopia of such an eye. With this, we are done with question number 25. Let's move on to next question.